Hi, and welcome to this section of the Advanced Calculus 2 tutor. And in this section, we're going to expand your mathematical bag of tricks, and we're going to talk about hyperbolic functions, which is a section that's going to be in your calculus textbook that talk about these hyperbolic functions. And of course, since you're studying calculus, you're not only going to learn about the functions, you're going to learn about their derivatives, okay? So the rates of change of these functions. How to take the derivative of hyperbolic sine is hyperbolic cosine. Derivative of a hyperbolic cosine is hyperbolic sine. There's no negative here like there are for the regular trig functions, but it's very similar otherwise. Derivative of the hyperbolic tangent, well, what is it? It's going to be hyperbolic secant squared x. Okay, very similar. And the derivative of the hyperbolic cotangent is going to, and the derivative of cosecant is equal to negative cosecant cotangent. Okay, so if you were to flip back and look at the derivative of the regular sine, cosine, tangent, cotangent, secant, cosecant, you would see that this table looks almost exactly the same. Derivative of tangent is secant squared. Well, here it's the same thing. Derivative of hyperbolic tangent is hyperbolic secant squared. Derivative of cotangent, cosecant squared. Same thing, going on and on and on. So everything is basically exactly the same. So that makes it easy to sort of memorize things. The only thing you need to really keep watch out for is on your test sometimes they'll have you do some problems dealing with the exponential forms of these guys. So you need to know that, and that's actually, those are very similar to the definition of the regular sine and the regular cosine, and that's why these derivatives work out so nicely. Okay, so what we're going to do is we're going to leave those on the board. That is just going to be what you find in your textbook. Okay, that's going to be what you find in your textbook, and what we're going to do now is we're going to work hyperbolic tangent of x. Okay, now it's this times the derivative of this plus this times the derivative of this. So we just write hyperbolic secant of x times the derivative of the first function, which is just 2x, because derivative of x squared is 2x. So you see it's the first quantity times the derivative of the second, which we found from the table, plus the second quantity times the derivative of the first, which is what you have here. And now all you have to do is just sort of simplify it and take derivatives. It's really nothing magical about it. You just apply the rules that you know from calculus, and you use these hyperbolic derivative definitions here, just as you always would, to go ahead and just apply them to the rules you know. Now we're going to switch gears and do some integrals, because you see, anytime you have a list of derivatives like this, derivative of cosine, hyperbolic is sine, and vice versa, you automatically know what some integrals are. So we're going to use that, and we're going to practice that here. So what if you had the integral of the hyperbolic sine of 2x with your integrals, your same tricks. You know, you can do integration by parts. You can do, your trig substitution. You can do, all of your regular substitution methods and everything else. It's just that now you have a few more things in your bag of tricks to play with, because some of these functions do pop up in engineering often. Okay, so what if I wanted to do the integral of the hyperbolic cotangent of x dx? Okay, the first thing that I notice right away is I'm going to go back to this cosine, because they're so similar to their regular trigonometric functions.